chapter 6 was fly high. Chapter 4 though, bogs you down. Now, I've got to ask, yep. We discussed logarithms, I think, yesterday. I think on this handout, one side starts out with properties of logarithms. Is that true? Does it say properties of logarithms? Now, Rita, is that, do you have also the original from yesterday, you want to pass out? Now, I just want to point out real quickly, something we have done already. That was our one, this. Let's do a definition. Guys, tell me, please, someone from yesterday, and yesterday was a demanding class. Anyone tell me what this means? That log of x, base A, equal to y. What does it mean? And we accept that as a definition of a log. What does it mean?
So A and Y.
A raised to the y is equal to x. Exactly. I think they have restrictions placed on so. That's what it means. I think the restrictions were, if you remind me here, I think they let what, A had to be positive, was it? And they did not want A to be a 1. And I think it's a reading for you here, I think there was a restriction on the x, which is like the domain. Anyone recall what that restriction on the domain was? X must be what? Greater than 0, positive. Okay, so the domain of a log function must be greater than 0, positive, and also the base down here must be greater than 0, but you can't let it be 1. If I see something like that, I know how to deal with it. We're going to deal with it here shortly, but first, just real quick, create something here. Say log base 1/2 of 32. Before I jump into some things here to do. Does anyone think they know the answer right now at this moment? I walk up to you and I say, what's the log of 32 base 1/2? And I have met my restriction. The x here, domain is positive, 32. And the 1/2, the A is greater than 0. So there's an answer. Yes? I hear -5. Joseph, if you say -5, you've got to tell the class why. Show me what it looks like here. That's exactly right. 1/2 raised to a -5 is 32. It's from basic math. That answer works out for me. Before I jump into, like I said, and do what I got to do here shortly, let's try another one here. LN, if I use that abbreviation, the base is understood to be an E. Remember that 2.718? So it's understood to be an E. It's not written though. Let's try LN of, why not? This. The square root of E. And give me a possible answer, then I'll use that definition so it makes sense. What do you think it is? Anyway. I heard 1/2. Let me see if it is. Now tell me what that looks like if it is 1/2. Marina, what is it?
It's
E
in the power of 1/2.
equals?
The square root of
That's exactly what it looks like. And that's a correct statement. E raised to the 1/2 is equal to square root E translated. And her answer of 1/2 is beautiful. Number 3. I'm trying to lead you into it before I jump into something here. Let's try why not. ln of a -8. Response there, no, rewrite it. No solution. But right placed on the domain here, it's going to be greater than 0. I tried -8, there's no answer. Or log. A negative there, no solution. Now, I know I'm on the handout here. All this sort of lead me into you that handout, and we'll get that handout done fairly quickly. Part C, before I jump into it. Here we go, bear with me. Am I ready for this? Boy, am I ever. Here we go. Find the domain. No sketches needed right yet. Find the domain of these functions. Hey guys, I brought a few in, and these may be on one of your handouts. I was looking at here. First one is f of x is equal to ln, natural log, x subtract 3. Open the domain. What may I replace x by? Are there some restrictions? And I can look at this right now and tell you I cannot replace x by 1. 1 subtract 3 gives me a -2, and this definition says stay away from negatives. Sure. Okay, now let's see what to do here. I heard the answer. Must this right here, it's called the argument, must this right here be this based on the definition? And if you solve for x, there's your domain. We put in interval notation, no problem. Replace x by anything bigger than 3, it's okay. Can I put a 3 itself in? I notice it says x is greater than 3. Can I put a 3 in? If I get 3, I get a 0. And the domain says what? No, you gotta find something greater than 0. So I cannot use 3. Number 2, before I jump in, it's a lead in to what I want to do here. Next one looks like this. H of x equals log base 3, and I have for the expression to be this. I want its domain. Want me, I replace x by and be okay. But it all depends upon this. So you must make, yeah, but you got to make this first. This, by definition, must be for a log function. This must be greater than 0. That's what it comes down to. Now, you know me as an instructor, I try to connect lessons. How you gotta solve that? How you gonna solve that? Look for a keyword or words that we've used so much in this class. How would you, as a clever student now, you've got to find the x now. How are you going to finish this up? I'll give you partial credit to show me at least you realize this has to be true based on this. Now, how are you going to solve that? How do you use sound analysis? How do you use sound analysis? Now, can anyone tell me my critical numbers on my number line when I start testing? Based on what you see, x over x plus 1? 0 is one of those test numbers from the top. And -1 from the bottom. And they're both open. We've done sign analysis like this before. Now, to save me a little time here, as you start testing, guys, I'm not going to show you my test numbers and so forth and so on like I usually do, but let's test it real quickly. Out to the left of -1, we'll try -2. That would be a -2 over a -1 that turns into a positive. Looks good if I made a mistake. I see a -1/2 in my next test between 0 and -1, -1/2. -1/2 over a positive 1/2 gives me a negative. I do not want that for a log. Out to the right of 0, I hope it works. We'll try 4. 4 over 5, positive. And I'm now satisfied what I want. Therefore, domain in interval notation would be -infinity up to what? -1 was it? Union 0 through infinity. Yes, that's domain. Before I show you the last one, you can do this handout. If this had been a square root function, not log, what do we do back on square roots when they ask you for the domain on a square root? out of curiosity. What do we do here if this had been a square root? X subtract 3. Yes?
Greater than or equal to.
Yeah, thank you. There's an equal mark. Greater than or equal to. Here for log is not equal. It's greater than. Last one here, guys, number 3. Let's find the domain on the last one. I think I feel good about this now. G of X. I think I threw in, what did I throw in here? All right, log base 2. X squared. The domain. Now you keep coming back here to the definition. I think I see one maybe you can't use.
Zero.
I can't use 0. And I guarantee you everything else will be positive. X squared greater than 0. Okay, but I can't use 0, so my domain would be, we'll put in internal notation, written like this. Do we agree? Now, finally, check my time here, my goodness. But you guys, do you appreciate those recaps we do at the beginning of class to sort of remind you what we had previously done and sort of tie in? Do you appreciate that, doing that? Takes a little time. Like I did a rational function before I jump into this and so forth and so on. Okay, now we're going to jump into the handout. On the handout, part 2. Karina, I think, at the top it says properties.
Yes.
Hang on. Properties of logarithms. And I think if you check your notes, I asked you for a logarithm, that's a strange word. Translate it, think of it as an exponent. Correlate it with exponent. So when you in your mind you think, oh, okay, it has something to do with an exponent. In other words, logarithm has something to do with an exponent. Let me remind you back from middle school, maybe earlier. I know those kids across the street are doing this. They're doing at least this. If you're saying, Professor, you want me to associate with the word logarithm exponent, and now you're going to look at some properties. You had back in middle school, properties like this. A raised to the m times a raised to the n. Who recalls what that property said back then? Okay, a raised to the
Power m plus n.
a raised to, she's telling me, m plus n. And they called that, I think, the product property. You remember all the teachers smiled and you smiled when you did this? Product property. Now there's another one that looks like this from middle school. What happens if you take a raised to the m and divide it by, it's a quotient, divide it by a raised to the n. What do you do with exponents from middle school then? You subtract. A raised to the difference, m subtract n. Quotient property. And there's only one more. Next one from middle school looked like this. A raised to the m raised to the n. What does one do with that middle school there? You multiply the two together, the two exponents together, and have a raised to what? M n. I think most middle schools call that the power property. You got product property, quotient property, power property. You got the three basic properties from middle school. Right here they are. I should put middle school here at the top, just to remind you. These are middle school. Now, we're here at pre-count. Now we've got these properties. Wait till you see what they look like. Arena, read the first one to me, and I'll write out as you see it on the handout. Product, okay. Was it log base A? Log base A. Okay, hang on. Log base A, okay.
M times n.
hang on now, that's a product,
Equals
equals,
logarithm base A of M plus logarithm base A of M.
like that. The truth? Now those kids across the street, they do this. They may over there, I don't know. I don't think they do this. In essence, we're saying the same thing. They say it this way, we say it this way. And there's your first property, it's called product property. It looks much like that property from middle school. Tell me what the second one looks like, Arena. Okay, quotient property.
Logarithm base A M divided by N.
Hang on now. Quotient, and what was the result?
Logarithm base A of M minus logarithm base A of M.
Got you. Like this one. That's where these properties came from. Now, the last one may look a little strange in the notation. Should be power property, the last one left. Tell this last what the power property looks like for us.
Logarithm base A of M in column R.
Okay, oh, they're using R, like this?
Yes.
And what did they say the property was?
Equals R times logarithm base A of M.
Ah. Now, what do they do? That one looks a little bit different than what they say in middle school, but in essence, we're doing the same thing. What did they do here? They just brought this R out front that she gave me, and we'll multiply these two together. Like they did back here, M times N. We're multiplying two together then. That's called the power property. Guys, I'm sure if you had any math, and you've had math, you've seen this somewhere. You've seen it something. You may not be paying much attention when it was presented, but you've seen it. Now, Arena, class, here we go. They all have the handout, Arena, but you're close by so you can help me. What was the next part on that handout? Since I now know the properties, what was I asking you to do?
Use the properties to divide the given expression.
Okay, to write a given expression. Again, and tell me what the first one is.
Natural logarithm.
Oh, LN, okay.
So it's fraction.
Oh,
5x.
Oh, 5x, gotcha.
5x square root 1 plus 3x.
Whoa, square root 1 subtract 3x?
Plus.
Oh, plus, okay.
Divided by
Oh,
x
wow.
minus 4.
Can we get
X minus 4.
x subtract 4?
Cube. All of that.
Cube.
Yeah.
And that's it.
Uh-huh.
Well, that's enough. Okay. Now they're asking you, can you, when you reach math 7, and let me confirm with my TAs. If they ask me to do a calculus procedure in math 7 or math 8, on something like this, we would prefer first, please simplify this first, Professor, and then do that calc procedure on this. Mr. Park, June, you guys do that? Did you have to break it up first and then do calculus on the pieces, the parts? That's what this is all about. So can I break this up into smaller parts by using the properties? Now, the way it's presented to me, Arena gave it to me, which of these three properties looks like it should be applied first? Product, quotient, power, the way this is presented to me. Quotient. The entire problem is a quotient. So we use quotient property, and that tells me to write like this. Ln, be patient, of 5x square root 1 plus 3x subtract ln x subtract 4 cubed. Let me step back and make sure everything's copied down correctly. Would you guys agree with this property here? So far, so good? Trying to break it down. Now, that's step 1, partial credit. Got to break it down as much as I can. Does anyone see another property over there that could be applied somewhere? I see something else I may want to do first. I understand what you did. What was that? product. Is this right here a large product?
Yeah.
5 times x times that square root. It's 3 factors, so I can split it up into this. If I split this up into those 3 factors, you can write this as what? Ln of what? 5, was it? Plus ln of x plus ln of this square root. Now that takes care of the first term, product. I'm going to leave this last term over here like it is for a reason at this moment. Okay, guys, I applied with the help of the student here, I applied the product rule in term number 1. Are we good? Now, does anyone see something else I could apply here using another property?
Powerful.
Power. There you go. There's definitely a power here.
Yes, and also.
Don't be misled. Thank you, Jimmy.
Also another one.
Is there a power here? So this really means, so while we're not overlook it, that square root, 1 plus 3x raised to a power of 1/2. I can now apply the power rule. That means ln of 5 stays like it is though. Ln of x stays like it is. Power property, let me bring that in and show you in color here so I can see where it is. Guys, if I lift that 1/2 out front, as I can, tell me, does it look like that? Making use of this property here. I move the power out front. On the end, I see another power. I can bring that out front and have the last term to look like that. Let me step back and look at it. Do you guys agree? And that's all I see to do with it. Some of my students get ambitious. Some of my students say, oh, Professor, I love this class. I understand all the concepts. You break it down for me. I can see, oh, I just love this class. And I give you a quiz, and all of a sudden I see a student say, wait, I went a little further, Professor. Oh, you did? You didn't stop at this point? No, Professor, I did this. On that last term. Is there a property of those 3 properties that would allow me to do that? No. We're finished. We've used the properties. I can't do anything else with that. You can't separate this down here. So no, the final answer is all of that. I'll erase a little bit there. All of that for the answer. And there it is simplified. Now, I'm work one more, then we'll take a nice break here. Arena, could do without you. Tell me, what's next?
Number 2.
Uh-huh. What they asked me to do with this?
Another assignment?
Oh, another one like this?
Yeah.
And break it up?
Yeah.
Oh, okay, well, in class with that. What does it look like?
Logarithm of base 2.
Oh, log base 2.
X times root square 1 plus x squared.
Whoa, 1 plus x squared inside here?
X squared, just x squared.
Oh,
Not
just
the
x?
whole expression. No, 1 plus x squared.
Oh, 1 plus, hang on now. Let me see what that looks like. Oh, just 1 plus x squared,
Yeah.
no square root.
Square root.
Square root,
of
nothing,
x
gotcha,
squared.
gotcha, gotcha, gotcha. Like this.
Yes.
And that was it.
Yeah.
Oh, my Lord. I'm asking you to use those properties and break the thing up. Guys, of the 3 properties over there, I would think it's a product. So if I use product property, split it up, and get ready for calculus, can I write this as log, and I think she gave me a base 2 here, x plus log base 2 of the square root. The truth? Am I finished? No. That square root actually could be written with what, power? So this says right here, Professor, don't stop. This means 1 plus x squared raised to what? 1/2. Now I have a power involved. And to finish this up, we have log base 2x that stays as it is. Now though, this 1/2 can be moved out front, power property. and have log base 2, well, it looks like left is this. Do we agree? Now, is it tempting though, is it tempting, to go over finish? Is it tempting to say, Professor, could you do something else with this? And if I take a close look at it, I know inside here is not a product, it's a sum. Do I have a sum property listed over here? I've got product, quotient, and power. There's no sum property for logarithms. That's all I can do with this. Wow, wow, wow. Take a breather. I noticed June sends out these beautiful, beautiful notes. And June, I've been telling some of my colleagues about you. I think they're going to be looking for you for a TA. If you guys missed out on what I'm doing here, and she's done it beautifully laid out in her notes that she sends to you, beautifully laid out. Oh, take advantage of what she does. And I noticed yesterday with so much material, she had lengthy explanations and things like that there. The little arrows drawn to show you go from here to here. Excellent, absolutely outstanding. Guys, any concerns up to this point though? Arena, was I finished with that particular part?
There's one more.
Oh, are you kidding? There's one more? Okay, let's get down the way. What is it?
There's no base, but it's longer. So,
Okay, just LOG, okay, I'll tell you about that.
2x plus 3.
2x plus 3.
Yeah, divided by x squared minus 2x plus 2.
Whoa, x squared minus
3x plus 10.
plus 10.
2.
2. Let's get down the way right now. And by the way, she told me, and some students may know, if they use the abbreviation LOG, not LN, if it's LN, it's understood to be a base E. It's not written though. Suppose it's an LOG, and the base is missing. Does anyone recall from past experience what the base is understood to be? 10. They call it a common logarithm, so it's missing, so it should be a 10 there for a log. My concern though is, let's apply the properties. Guys, quotient property, take a break here. Let's write this as log 2x plus 3, I'll be patient here, subtract log of x squared, subtract 3x, which you gave me, plus 2. So you say, Professor, definitely there's more to be done here. That's quotient property. First term, no. Can't do anything there. Tell me what might I do here, which we should, on that second term. The factors. Wow. So this is going to factor into, looks like x subtract 2, x subtract 1, and therefore, since I factor it, now it's a product in the red. So let's apply the product property. Be careful, guys. When you apply the product property, this now becomes log, I'm just going to be base 10, x subtract 2 plus log x subtract 1. Let me close that up. It looks like that. Is that true? And that's all I can do with it, unless you want to do this. Put this in brackets here. You could rewrite this as log 2x plus 3, and that subtraction or negative is being distributed in red on both of them, and you have this. Looks better. And there's your final answer. There, I'll be down there. Jeez. Is that true? Now, we're gonna take a break, but before we take a break, math professors talk. When we get to ourselves, we talk. And we talk about students. Not particular names of students, no. We talk about classes. Ramsey, how's your class doing? We talk. How's your class doing? I'll talk to another professor. We'll get feedback from each other. Where are you right now, Ramsey? Have you started to trig yet? We had that discussion yesterday. No, we started trig today. Are close to starting to trig? Professor said, yes, they were also close to starting to trig. So we had little conversations. So I told, those calc instructors, Math 7 instructors that are here this winter, I have some of the strongest students to send you spring semester. So get ready, because they should be strong. Should be the top of your class in Math 7. So I'm gonna be bragging on you guys. Don't let me down, because if you let me down, I'm gonna find you. I'll find you. And I'll go, PK, Anthony, Arena, I'll find you. Philip, I'll find you. I said, what's going on? What's going on? We worked so hard in winter session, you got a good grade, final grade, and you're messing up in Math 7? That's not gonna work. And some of my friends, those colleagues, they don't mind if I just walk into their class and I stand behind you. I've done that before. You don't realize I'm there at first, and all of a sudden you turn around and say, oh, that's right, what are you doing here? I'm checking on you. We talked, I heard something about you. You didn't do too well that last quiz. I will find you. But don't miss out. Guys, take your 15 minutes break, I'll see you. 2:15.